A very good afternoon, all, and welcome to XNECO's webinar series. Our topic for the day is PSP, the sustainable catalyst in India's net zero transition. India's declaration to achieve net zero by 2070 needs to be backed by concrete steps by the government and the private players to make it a reality. And by the year 2030, there are three targets to be achieved, which are as follows. First, India will increase its non fossil energy capacity by 500 gigawatts by 2030. Second, India will meet 50% of its energy requirements from renewable energy, that is non fossil fuel, by 2030. Third, India will reduce the total projected carbon emissions by 1 million tons from now onwards till 2030. When we talk of renewable energies, they have their own strengths and limitations, and these dynamics make PSP crucial for the renewable energy era. Our esteemed speakers for the day are Mr. Sanjay Rana, Managing Director, Parson Overseas Private Limited, and Chairman Aqua Foundation. He is awaited. Mr. Jayaraman Punithan, Vice President and Head Mergers and Acquisitions, Policy Advisory, PSP and Hydro Adani Group. Mr. Amardeep Kaushal, Director and Advisor, Unmukh, advisor and mentor for Google developer group Rachi. We also have Mr. Raghu Veera, head projects, project management expert, competent interest inspectorate and consultants private limited. He is also awaited. So we welcome you all, sir. Um, we are truly honored to have your presence at the web series of XNECO. My first question goes to Mr. Jayaraman Punithan. Kindly enlighten us about the various dynamics of renewable energy resources and what role PSP plays in the same.
Yeah, thank you very much. Firstly, let me thank Exnico for giving the opportunity to interact in the session on pump storage projects. And I mean, uh, my wishes and to the other co-speakers also. Just to give a very brief introduction of myself and then to answer what you have asked. So I had the business development for the pump storage and hydropower projects at the Adani Group. I'm also into policy advocacy, M&A, and acquiring new projects in this domain. So to come directly to your question of, see, in today's world, as you rightly pointed out, the commitments of India towards the global, net zero targets. So I think we are also part of the same targets that we want to take forward. Firstly, about renewable energy. Renewable energy is a very clean source. Most of it is, there are various sources, but predominantly it is going to be solar and wind and hydro. Of late, pump storage projects have taken gain because of its inherent capacity to adopt to the intermittent variable renewable energy of especially solar and wind. So if you look at the Indian scenario of power demand and supply, we will realize that most of the peak demand is in the morning and it's in the evening time. So and if you look at the supply of solar, the generation of solar, it is more, the peak is in the high. So in order to leverage on the availability of both the demand and the supply, pump storage projects play a very important role, especially to cater to the evening peaks and the morning peaks. Of course, there are various use cases for pump storage projects. Energy arbitrage is just one case, but there have been, it can be used as an ancillary service. It can be used as a transmission asset. It can be used to regulate the grid. There are various options for use cases for the pump storage projects. But the important aspect is energy arbitrage, of course, and also the round the clock solution. When I say round the clock solution, most of the companies, the global companies, the C&I customers are interested in getting green energy 100%. So we all know that most of the base load is coming from fossil fuel energy. So now we are trying to target a green round the clock solution. When I say round the clock, typically it should not be, I mean, it's not 24 hours, but maybe it's 16 hours or 20 hours or something. But still, what we are trying to do is we are trying to charge the pump storage projects during the daytime and trying to utilize that during the peak times. So this is the major advantage of pump storage projects that is coming. It is environment friendly, it is clean, green, and it is long term. If you look at the long term sustainability, it lasts for minimum of 40 years. Of course, we have examples of projects lasting for more than 40 years, but typically for the useful life of the project, we consider it as 40 years.
That is wonderful, sir. That was a great input. In fact, it also points out that how vital PSP is and how it helps to balance the solar and helps during peak hours, the transition and also in transition. Thank you so much for your inputs. Now, my next question goes to Mr. Sanjay Rana. Kindly enlighten us on geophysical investigations for pump hydropower projects, keeping in mind the techniques for enhanced site characterization and risk mitigation. Sir, you're
It's
muted,
a
sir. Yes.
right,
Yeah.
right. I have unmuted myself. Thank you for
Yeah.
that.
Thank you, sir. Yeah.
So yes, it's a very important point, but because there is a distinction between the way we are dealing with hydro projects, the conventional hydro projects, and pumped storage projects, and distinction comes obviously by the nature of the projects, which are totally different, and also the kind of time which we are allowing for the entire project development. And that's where this entire concept of use of geophysics for site characterization and risk mitigation becomes very, very important. To start with, I'll start with a very famous quote, which was the engineer's first problem in any design situation is to discover what the problem really is. Whenever we are designing any project, it can be a pumped hydro project or it can be any project for that matter. The first thing is to define the problem itself. So, problem definition becomes very important. Investigations become very important. And third very important point is avoiding assumptions. So this is the let's say start of the story where geophysics comes in picture, because when we are talking of investigations today, how we are doing investigations in most of the projects, we are relying completely on drilling, right? Now, drilling is giving you point information at that particular place where you are doing the drilling, whereas the information which you need is much more continuous in nature. That is, you should have information of the entire area which you are going to build upon, and that's where these methods come in picture. For the uninitiated, those who have not experienced geophysics, I always like to give an example of how you understand geophysics in a very simple way. Is that you have these medical imaging techniques, like you have X-ray, you have ultrasound, you have CT scan, you have MRI, etc., etc. Now, what is the purpose of all these methods, all these techniques, medical imaging techniques? That is, if you are having a problem in your body, or if you want to investigate your body, you first would like to do it in a non-destructive manner. Okay, you do not go to the surgery and you do not go to the operation theater to get your body cut open to find the root cause of a pain, which let's say you're having in abdomen. So you send certain kind of rays and waves inside the human body to create a picture of what is inside, and based on that you decide on the next course of action. Similarly, in case of geophysics, what we are doing is we are sending different kind of rays and waves inside the earth, or measuring the naturally occurring fields which are there, and based on that we are finding out what is inside the earth, where we are going to put our project, and based on this information we are going to make the entire design. Why it becomes so indispensable, especially in the case of PSP, is first of all the speed at which these surveys can be conducted. Entire site of a PSP for all its components, which I'll come little later, can be investigated in a matter of weeks. We are not even talking of months, right? So rapid coverage is the first thing. Low cost obviously goes without saying that the cost of X-ray is always less than the cost of surgery. So these are low cost methods. And the biggest point is continuous information. As I always say, that let's say you have done a drilling here and you have done a drilling here, and in between these two drill holes, you are having some fracture zone or some fault and things like this. You will not be able to detect it by drilling alone because drilling is giving you discrete information. What you need is continuous information that comes from geophysics. At the same time, it's very important to note that geophysics is not replacing drilling, right? It is optimizing drilling. Today, the practice is that we do drilling, let's say every 50 meters, every 100 meters, or in this entire area, let's do 4 drill holes. That's a random approach. Okay. By that, your risk still is there because the information which you are getting for your design is fraction of the information which you actually need to take an informed decision. Whereas if you do a good geophysical campaign, you can map the complete area, find out the zones which need further investigation, and then only do optimized drilling at these places. What it does, it basically results in minimization of surprises. Today, if you talk of any civil engineering project, be it tunneling, be it PSP, be it any project, we as engineers always come up with a term called geological surprise. That is, if we met with a particular situation which we did not anticipate, we say, oh, we met with a geological surprise, and based on that, the project cost will go up, the project time will go up, etc., etc. But if we have continuous information on the subsurface, these surprises are minimized. In the basic context of PSP, we can actually count on fingers the investigation objectives. So obviously, the first one is your dam site, which is the foundation of dam and other structures, spill, etc., etc. Then is finding out the geology of the area to be occupied by reservoir. Now, PSPs are being constructed in various areas, including Deccan, where there are certain zones which might be natural seepage zones from the reservoir unless we map them properly. So, the geology of the area to be occupied by reservoir is another very important thing. Then stability of slopes. Once the reservoir is filled, what is going to be the stability of the slope and in the reservoir area so that landslides do not happen. Okay. And then of course, once you're making your dam, you need information on construction materials which are needed to be built for the dam, etc. All these objectives, and other than that, you can list number of other objectives: hydrological, foundation design, EIA, seismic hazard assessment, construction planning, etc., etc. For meeting all these objectives, geophysics comes in very handy. As an example, there is a technique called seismic refraction tomography. Now, if you conduct a seismic refraction tomography, you get a continuous profile of your, let's say, topsoil layer, weathered rock, compact rock, etc., etc. You also can map presence of faults, fractures, geological stability of site, compressive strength. So this is a very, very important data which goes in designing the whole thing because you need continuous information of the rock. You also need information of any faults and fractures which might be present there. Similarly, there is a method which we refer to as seismic resistivity imaging. This is based on mapping the contrasts in the conductivity. This method becomes very important to find out to map, for example, lineaments in your reservoir area, which might become conduit of seepage if you are not mapping them beforehand, right? Once the reservoir is filled. So electrical resistivity imaging becomes very, very important for that. Then you have MASW, multi-channel analysis of surface waves, which is very important to understand the shear parameters of the site, which means earthquake site response or liquefaction analysis. So hazard, it's basically it is used to evaluate the seismic hazard, which again is very important parameter once it comes to PSPs. So you see, if you take all these methods together, what we are doing is that we are making our investigation more efficient. We are making investigation faster. We are able to finish the investigation in a very very short time, and also multiply the information hundredfold, because you can imagine the difference, that one drill hole here, one drill hole here, in between it's all assumption, it is all interpolation. So once you have the continuous information, we are basically eliminating this part of assumption and interpolation, ultimately leading to a safe design, a well informed design, rather than based on assumptions only. So this is the broad role which geophysics plays in the site characterization and also the risk mitigation. Because if you do not know about your underground, risks are infinite,
Unlimited. Yeah.
unlimited, absolutely. So that's in brief what I would like to say on this point.
That was a very wonderful input. In fact, when we talk of geophysics, you gave a very good example that it's better to do a CT scan than an operation. So it brings down the cost. So it really is very helpful method. And now we would like to go to our next question that is directed to Mr. Amardeep Kaushal. Mr. Amardeep Kaushal, please bring into light the work done by Unmuk and its endeavor to develop energy from waste, and as well as the latest innovation of developing water from moisture.
Yeah. So first of all, very good afternoon to everyone. And I'm in a little bit low network area outside the city. For uh, Now, coming back to Unmuk, what we do is we produce green coal, which is biopellets from the farm waste. We are the only producers or manufacturer in India who are producing green coal for thermal power stations and other coal bearing plants. Here, what we do, we use our paddy, waste and groundnut outer shell, cashew outer shell, and few other plants, as a raw material uh, for manufacturing our pallets and all. Currently, we have a test filing unit in Bargarh in Odisha with a 50 ton per day capacity, and currently working with companies like NTPC, Hindalco, Balco, Tata Steel. We are supplying to them. Coming back to the kind of role which we are going to play, in net zero and also the carbon emission sector, the carbon market sector is humongous because the kind of demand which was there last year was something around 4.5 lakh crore ton of biopellets has to be supplied. And if you look at the actual supply which was being made was hardly 2 lakh ton. So there's a huge demand and supply gap, totally driven by the sellers. And if you look at the data, still we have 55 to 60% of the entire energy sector is dependent on coal itself. Our product is going to replace coal, and there's a notification from the government of India where 5% of the coal use has to be replaced by this, biopellets or already renewables products which can be used in the blast furnace itself. This is one project which I am part of. Another one is we are also producing, fresh drinking water from air moisture, where we have we have put up a plant in in near Hyderabad, and we are working on a couple of areas, domains, especially in coastal areas where we have high density of humidity available. Uh, and it's working pretty well over there. We are working with a couple of government machineries like railways and all. This is like pure form of water which is available in the world right now as per the WHO report, and we are trying to see if we can use this water for agriculture purpose. We have put up in one of the village near Kolar in Karnataka, and we are supplying to 200 households and also for the agriculture purpose also. The produce is really good, and we are looking forward to see how government of India is going to take up this opportunity to a next level. So this was about from my end, sir. Any questions? Definitely, I am ready to answer.
Yes, we also have our knowledge member, Mr. Raja Mohanty over here. So, sir, if you have any questions, you can ask Amardeep, sir,
Yeah, I
regarding.
have one. Well, thank you so much. I have a one understanding on the atmospheric generated
Yes.
water that you are using only for agriculture. Can that
Yep.
also be used for drinking at some point in
Yes.
time or through some treatment?
No, sir. Actually, we are using it for drinking purpose directly, and also for farming. So for farming, we have a case study which we have put up in the Kolar district, and where we are doing farm, we are using that water for farming purpose also. The produce is really good.
Right. So thank you.
That's wonderful. So, as we enter into the renewable energy era, there are
Thank you, sir.
so many
Mm.
alternatives coming up, and even government of India also has given directions for use of bio pellets instead of coal. A certain amount has to be used. That directive has also come from the government. We also welcome Mr. Raghuvira for who was awaited. So my next question goes to Mr. Raghuvira. Please enlighten, please bring into light the work done by, the crucial points to be kept in mind while construction of industrial building and the safety measures that are required to be taken. Like we are talking about PSP projects, so we would like to know how industrial buildings and all and the safety measures that have to be taken while doing such kind of constructions.
Uh, Thank you very much, madam, and good afternoon to all. And first of all, sorry for delay in joining your meeting. Uh, and the question what you asked related to one is the safety aspect. Second one is related to the energy embodiment and greenhouse gas effect, how to be reduced in a residential buildings and industrial buildings. So the first one is actually the energy conservation point of view. There was a we are having a 1 minute. I will show you this one. Embodied energy. Generally, we will do audits on residential buildings. Basically, it will consist of a methodology which is having a study of available what are the materials are used in a buildings, as well as identifying the different methods of calculating the embodied energy, also collecting the working drawings of the buildings and preparing the estimates of embodied energies, and also calculating the specific energy of general materials, and another one is selecting the building components, and third phase is, like us say, identification of different energy efficient alternatives for selecting building components, and fourth one is, let us say, analysis of different alternatives of selected building components with respect to cost, strength, and embodied, and the recommendations of the energy efficient materials, and also finally the suggestions and recommendations for a how to be reduce the greenhouse gas embodied energy considerations. So any in my overall industry experience, basically the designs will be done and it will be released for a construction purpose. So the construction team basically they will follow whatever the design has been given and what are the specifications has been given by the designers and architects and planners. So the focus is for the reduction of the energy, the emission of a greenhouse gas effect, and the reduction of the greenhouse gas effect is purely at the initial stage of the planning and designing stage, as well as the planning stage, uh, is generally involved. So there are the three aspects is involved into the calculations of a energy conservation and energy utilization. By that, actually, whatever the greenhouse gas effect we are as an individuals or as a planners, as a construction people or a developers are doing. So it will consist of a, actually, when the material, any materials they are selecting, so it is to be considered from the materials extraction and transportation to the manufacturing yard. So how much energy has been considered, and based on that, how much greenhouse gas effect we are doing. And the second one is from the manufacturing yard to the transporting to the place of the construction. So it is again the energy considered, energy consumed for transportation of material from one place to the construction part. Because of that, how much energy has been consumed and how much greenhouse gas effect is we are contributing by the construction team or construction of your projects. And third one is the during construction of a any industries or the institutionals or any sort of the heavy industry or medium industry or heavy industry. So construct during construction process, and what are the measures has been taken and how much energy has been consumed, and because of the construction, how much greenhouse gas effect has been involved into that. Then fourth one is once the operations are over, the project will last for a that life period. Then it will be demolished and it has to go to the cradle. So that after the dismantling and the debris or whatever may be the products is coming out of the non-usage of that afterlife period, and transportation, and again it is the utilization or non-utilization or final disposal, how much energy has been consumed, and how much greenhouse gas effect has been generated because of that. So we can say it is like a born to cradle. So has to be considered for any of the aspect in this buildings or the industries or any sort of construction. So how much greenhouse gas effect has been created by because of the manufacturing, raw material exploration, manufacturing, transportation to site, and construction. Then after life period, the demolition and going to the reutilization or non-utilized materials aggregation and disposal. So this is the way a team of people has to be keep in mind while doing any of the design plan and all these sort of things. So you coming back to the how to all individuals or as a professionals has taken care while in my during a tenure of my construction period or the planning stage period is the one is selection of the materials very available nearer to the our construction area, so that we can reduce the transportation point of view, the energy consumed. So the point we considered during the construction phase is the people who are deciding team was there to select items or the materials which is to go into a construction to be made, which is considered, which are available very nearer to the place of the construction. So, for example, any materials which are available nearer, but sometimes going for a farther distance for a price point of view. If some small gap of a price discounts are there, so if it is considered as a longer distance procurement, sometimes it will happen. In those cases, also by keeping in mind the GHG point of view, the materials has to be selected at the lower distances. One way it is the education to be or awareness to be created for the commercial teams and procurement teams as well as the managements were to consider to reduce the transportation point of view. And second point is the different materials. Basically, I am talking in the point of first initially civil will start in any construction. For example, the type of materials used for a construction, let us say concrete. So the concrete embodiment energy is different for a regular concrete than the concrete by using a fly ash cement. So the consideration for the utilization of the concrete by using blended cement with the fly ash will be a lesser energy consumption. By that, the greenhouse gas effect will be lesser than the concrete which is using with a regular cement. Like that, if we are going for a uh, sand or a aggregate or a reinforcement steel, so there is a different energy consumptions for the different materials. So if you see, let us say for crushed sand, the electricity consumption or energy required is, let us say, 20 megajoules per cubic meter. And the same thing, if it is a river sand we need, we means the construction team has to go for a energy required for generating is around 37 megajoules per cubic meter. So the difference is almost 17 megajoules per cubic meter of a sand. If used, river sand is more consumes than the crushed sand. So these awarenesses for the people of to be generated to all team, let us say designers or the planners or the developers, to consider not only the price of a material, has to be considered the energy emission characteristics also while selection of a materials utilization at the sites. In the same way, we can have uh, the materials which are used for a glass in a construction industry. The glass should have a film. The film should be capable of sending a light inside, but it should not send the heat to the inside the rooms. So this is the one consideration while designing or planning stages has to be considered. That is the one of the experience we have come across. So that because generally they will write in your specifications, a white tinted glass has to be provided in your windows. So instead of that, it has to be mentioned that the glass with a film, the film also should have the characteristics of allowing a light but not the heat. So those things are available in India and all the places. By that, they can reduce the greenhouse gas emissions in over a period of operation stage after the construction. In the same way, the when we'll go for a, let us say, the open glasses area provided in the ratio of a wall area shall be higher than the what they are following in a constructions nowadays. So the percentage of the open areas shall be more than even specified in the specifications. So instead of following the lowest specifications ratios, can go for a higher ratios so that the daylight can be utilized even for a daytime. By that, the reduction in the utilization of a electricity by a universities or the educational institutions or a buildings or anything can be reduced, and by that reducing the energy consumption, again the greenhouse gas emissions will be, we are contributing to lesser quantities. In the same
Wonderful,
way,
sir. In
in the
fact,
same
very,
way,
yes, sir.
please,
Yes,
please.
please continue. So, in fact,
So
the inputs were very good. In fact, we have to, when we think of PSP as a sustainable, answer to the energy problem, we can also we will have to also think that at the point of construction whether it is sustainable or not. So while constructing a dam, while constructing the project, at that point of time also we have to keep in mind that the project is sustainable, the materials used are such that the greenhouse gas emissions is less, and even the project when it is fully functional, that time also the applications should be such that it's more sustainable. And also with the kind of inputs we are having in the discussion, we can bring down the cost of the projects as well. So my next question goes to Mr. Punetan. PSP PSP can act as water batteries, but can they double up as water reservoirs as well as water irrigation projects to justify the capex and their long-term functionality for around 40 years?
Yeah. So thank you very much. I think see, PSP has two reservoirs. One is an upper reservoir and one is a lower reservoir. So in terms of using that for irrigation, because most of the PSPs are large infrastructure projects, and if you look at the appraisal system, the Central Electricity Authority and the Central Water Commission, they do the appraisal based on river valley projects. Though there are some offstream closed loop projects which does not exist on a river, but still the importance comes in PSPs acting as water batteries. So when we try to treat this into an irrigation or something, there are a few examples. One is that the nature of the project becomes a multi-purpose project. So the approvals for a multi-purpose project is different than a specific standalone PSP. That is the first thing. Now, having said that, we do have, for example, this Chitravati project. We also already have a balancing reservoir in the lower reservoir. So there is already an existing reservoir. What we are trying to do is we are trying to construct an upper reservoir and then try to bring the water from the lower reservoir to the upper reservoir. So in terms of use case, I mean, we most of the developers are more comfortable to keep it as a standalone project rather than mixing it up in terms of whether it is a multi-purpose project or an irrigation project. The purpose of pump storage project is to act as a water battery to try to give out the energy at the time it is required. So I think it is much better to stick to standalone projects. I mean, most of the developers, the private developers, are also in line with this thought. It is much better to stick to this standalone PSPs and the reservoirs.
Okay. So my request to Mr. Mohanty, is there any questions? Would you like to ask any question to our panel members?
Yeah, one to Mr. Punidan, a very stupid question for my understanding. So, when you say a reservoir is a standalone one, does it have any similarity with what happens in these in-stream water storages which people use or governments use, where they try to capture the rainwater primarily? So, does that have any similarity of use? Or are they completely different?
I mean, see, thank you very much, Dr. Mohanty. I mean, this is more relevant question actually. It is not a, I mean, big question. This is very relevant because when we try to understand the types of pump storage projects that are available, there are on-stream projects which involves a river, and there are off-stream projects which does not involve a river, but basically you try to have a one-time filling from a nearby river and put it in one of the reservoirs. So this is how. But when I say it is standalone, that means most of the private developers are more interested in off-stream projects. Why off-stream projects and why closed loop projects? Because the environmental, I mean, risks or the environmental when we are talking about long-term sustainability and all. In fact, closed loop projects do not have any rehabilitation and resettlement. They do not they do not involve much of, uh, environmental problems as we face in conventional hydro. So that is the reason that most of the private developers are interested in developing closed loop offstream projects. I hope it answered your query, or you want to elaborate?
No, no,
Need to elaborate?
absolutely.
Yeah.
Absolutely, it did. It did. Thank you.
So my next question goes to Mr. Sanjay Rana. How application of geophysical methods expedite the development of PSP, and what is the status of these practices in other countries?
All right. So, you see, as I discussed in my earlier part of discussion, the application of these methods are expediting the process by enhancing site characterization, identifying geological hazards, and ultimately optimizing the engineering design. Now, if you look at various components, first is site characterization. So, like I said, seismic refraction, reflection, electrical resistivity, these are providing detailed information about the subsurface condition. And this data is crucial in determining the suitability of a site for reservoirs and underground powerhouse. So, if we go for traditional methods for site characterization, they are much more time consuming, and of course, you do not get the complete continuous data as against the geophysical methods. Second is the hazard identification. So potential geohazards such as fault zones, fracture zones, area of weak rock, which ultimately could impact the stability and safety of the storage facilities. So hazard identification is another very very big reason, which if you do it correctly, it expedites the process. If you look at any project for that matter, civil engineering project, we always say that we'll finish this project in 3 years of time, but we end up finishing the project in 10 years of time. What happens there? We keep meeting with the subsurface conditions which we did not expect. We call them geological surprises. We handle these situations which ultimately lengthen the entire process of project completion. Then next is design optimization. So by accurately mapping the subsurface, these methods actually enable engineers to design structures that are more efficient and safer. So it reduces both construction cost and time. More the information you have on the subsurface, more accurate is your information. You can definitely design better, more efficiently, and ultimately reduce your construction cost and time. And environmental impact is the last point. So these methods are totally non-destructive, which means that they have minimal environmental impact compared to traditional drilling method. This aspect is crucial in maintaining the ecological balance in areas selected for PSPs. I was recently in a particular conference on PSP, and we were talking of this forest permission, etc. Even for the basic initial investigations, that okay, for drilling this permission is required, this permission if you talk about geophysical methods, practically no permission is required anywhere, for the simple reason that you are not leaving any footprint on the ground once you are doing the job. You are not doing any drilling, you are not cutting any forests, you are not doing anything on that. Okay. Coming to the next part of your question, that is, what is the status of these practices globally? See, I've not interacted much with the PSP developers globally, but I have been interacting with the developers who are doing some good work in India, and they are visiting places like China very frequently these days, because China is one of the leading countries in construction of large scale PSP. And what I understood talking to them is that they are using geophysics extensively. That is, when they are starting the project, even before that, you can say the pre-feasibility part of it, all that, they're extensively using geophysics to make sure that site is right, what are the site characteristics, what is the rock depth, etc., etc. And from that phase to almost complete information investigation for the design, they are depending heavily on geophysics, and only in few cases they are going for drilling only when it is required. That is how it is being done globally. We are lagging behind in adopting geophysics in India to that level as of now. We are still having a lot of reliance on drilling, which, as I said, is mandatory but optimized drilling. We already define our tender documents, for example, that these are the minimum number of holes which should be done, and this is where it should be done. Now, it basically defeats the entire purpose. You already have decided where you are going to make the cut for the surgery. irrespective of the result of the ultrasound and X-ray. Now that doesn't make any sense. You have to first check where the cut is required and then make the cut there. And now we know laparoscopic surgery is there, that sometime without making a big cut you can actually do the surgery and remove the problem. So if you are able to optimize your drilling based on these results, that is the way to go forward.
True. Wonderful, sir. My next question goes to Mr. Amardeep Kaushal. Mr. Raghuveera, what measures should be taken when it comes to budget planning of such high capex projects?
Myself, madam,
Yes,
Raghuveera.
sir. Yes, sir.
Okay. Yes, yes. So, while going for a deciding for a budget factor, we'll generally arrive on a four parts. One is for a engineering point of view and availability of land point of view, then materials and construction cost and operations cost. So while going for a budgetary of all those things, so generally we'll take a some preliminary similar projects as a benchmark, because for doing a ratio basis for arriving to the cost of a major projects, or and because at the initial stages we will not have a 100% details to arrive, and there will be a unexpected things will come in future which will attract a very huge amounts also. Those things will be considered in a risk mitigation plans by making a list of items which may come at a future stages, and for that also some percentage of the amounts has to be kept as a contingency as well as a unexpected expenditures for a percentage wise. So overall the budgetary after arriving, so in past experience what happened is it's always a dynamic in nature, from the day initiation or inception to the implementation and the handing over stays and operations. So there are a lot of environmental, I mean to say, a lot of factors or effects internally and externally to complete any of the as a final project. So in that case, what we have observed is almost all the projects, though it is envisaged for, let us say, 4 to 5 years project, or some are 2 to 3 projects, for the real completion of a projects, or went at least 10 to 15% of the overtime of after taking a meticulous plan A solutions, plan B solutions, all those things. So to arrive the budget, after arriving the preliminary budgets, it is required some percentage of amounts has to be kept for arriving at a final budget. So this is what happening in a major capital projects, and plan B action has to be there to complete successfully, and to arrive to a situation that yes, this is operational stage and commissioning stage, and it can go to a public for a service to the society. Thank
Wonderful,
you.
sir. Yeah. So that was also great input, and how dynamic the nature of the budgeting is, and that was those were great inputs. So, Mohanty sir, do you have any question at this moment, sir?
No, I don't have. Thank you.
Okay. With this, I would like to ask one common question to all the members. What kind of public-private partnership is needed in PSP sector of India?
Yeah. Should I answer or?
Yes, sir. Yes, sir.
Yeah, okay. The PPP mode has already been conceived by many of the state governments. For example, if you look at it today exactly in Tamil Nadu, they have released the expression of interest for a public-private partnership for calling for, I mean, uh, PSPs, expression of interest. They are trying to develop this as a public-private partnership. They have identified a few pump storage projects already, and they are putting it out for bidding. But there have been various other ways where other state governments have adopted a different way. But I think public-private partnership will go a huge way in developing all the most of the on-river systems or the identified PSPs.
Wonderful. Dr. Sanjay Rana, do you have anything to add to it, sir? Sir, you're muted,
Uh,
sir. Yeah.
yeah, I realize that. So I said he already covered it very nicely. And the point is, if you look at PSP, this is actually a fine example of public-private partnership in India. PSP is being developed where a lot of private partners are involved, and state is supposed to basically facilitate the entire process. They are supposed to make the entire process easier for them, give the required permissions. The only thing which is still happening is, if you look at the regulation and regulatory bodies, we are still not giving enough, you can say, free hand to the developers. We are not trusting their own capabilities in doing deciding things. Okay, because if you look at the entire scenario, they are investing a lot of money in the entire project, and any private developer will be absolutely foolish not to know what they are doing. Okay, so our permissions, our sanctions, etc., can definitely be made more easier. Although I must admit, government has done a lot in that direction. Single window clearances and these things are happening and they are in progress, but we need to work more on that.
I'd,
True.
I'd, I'd just like to add to what Dr. Sanjay Rana has pointed out. He has made a very, very relevant thing. When the state governments come out with the bids for the PPPs, usually what they do is they try to prepare a pre-feasibility report, onboarding a consultant, and then try to prepare a pre-feasibility report or something. Whereas when the developers come in and they want to bid, maybe that design might not conform exactly to the threshold values. For example, if there is a high head between the low reservoir and the upper reservoir, and that is costlier, so it has to be viewed in terms of cost and the normal L by H ratio. That is where the developers are more concentrated. So I think there is some disconnect. So what I would like to say is that there should be some kind of open where the developers should be allowed to change. But what happens is the developer has bid based on the preliminary design, and then he goes out and then he tries to build another design which is more suitable for under his threshold values. So there is some mismatch which we are already discussing with most of the state governments, and I think this is very, very relevant aspect.
True. Like before we conclude, my last question goes to Mr. Amardeep Kaushal. Kindly enlighten us on water as an asset and where does India stand when it comes to water conservation?
Thank you for this question. Actually, I was having a discussion with one of my mentor. He was an ex-ISRO chairman. We had a discussion like, he asked me, tell me the reason for Third World War. I said, sir, it might be, I might be wrong, but it might be because of the fresh drinking water reservoir. If you look at the entire Indian, subcontinent, we have, rivers flowing from Himalayan region and all. Problem with us is like, the kind of waste which is going into the rivers itself and getting contaminated, which is not fit for drinking. Somewhere I see the government, more than the government, it's like the role of the public and the people who are and the industrialist, ecosystem, where they need to take some steps, in terms of either doing some kind of recycle stuff or some kind of waste management treatment and all that else. I'm seeing, in the coming years, the things will be in a totally different shape altogether. Just I'm in Bangalore right now. People are started talking about, the Bangalore will become dry in the month of April. again we'll have a water shortages and all. I feel a lot of you know preventive measures has to be taken from the government side, and definitely people who are doing innovation in water conservation or water reservation, they should be they should work with them actually, and provide them some kind of support, else things will not move. In my other projects also, which I spoke about, which was the biopilots, I still believe more than the government support, we need intervention from the private parties, because we somewhere we find out like lack of funds stops becomes a bottleneck on doing or executing any kind of innovative projects. So there is something from my side. Maybe I hope I might have answered your question.
Yeah, sure, sir. In fact, it was a very, I mean, good input, and also the discussion was quite enriched, and we came to know a lot of aspects. Before I conclude, I would like to welcome the panel members to add if there's anything they want to add to the discussion. So, if they feel they would like, they are most welcome. Even yes, sir.
Yeah, yeah. I actually, I not want to add, but I have a question to Dr. Sanjay Rana because he was very well pointing out on the extent of investigation, the geophysical investigation that is required. In fact, we have been facing a lot of challenges as to how much investigation is optimum. And one important aspect, sir, is about the liquefaction analysis, which you told, the liquefaction index, because most of the reservoirs are coming into contact with that rock, and when the rock behaves with water, then it turns into a soil kind of liquid form. So this is one important aspect which we are also been stressing out. So of course there have been geomembrane protection all over for the reservoirs, but what will be your suggestion to see if on the bottom of the reservoirs? What will be your suggestion if you have? I mean, I have two questions. One is, of course, liquefaction index. Is this something which is very mandatory and it has to be gone through for by the appraisal agencies? The second is that if it is mandatory, and what are the ranges, and how do you deal with the bottom?
Okay, so that's where investigations come in picture. Okay, for even this particular aspect, liquefaction aspect is one. Then seepage and leakage to the reservoir is another. Especially when we are working in Deccan areas, we are dealing with the rocks which have never come in contact with the water in their entire history. Okay, how they are going to behave when they are in contact with water is one. How the lineaments are going to behave when they are filled with water in the reservoir area is another aspect. And for all these aspects, we have to focus more and more on investigations. Unfortunately, today investigation is one of the most ignored area in the country, not only in PSP, in any project. World over, the average spent on investigation is something around 5 to 7% of the project cost. In India, you will be surprised that we are investing 0.5 to 0.7% of the project cost on investigation, right? That is one. And the time allowed for investigation also is always the least. The project is getting delayed. The only activity which is cut down is investigation. Okay. So there has to be more and more focus on investigation if we really want to complete these projects in time within the allocated budget, which is something which is mandatory for PSP. We are giving X number of months for the developer to complete PSP. So if developers themselves are not adopting the new technologies and they are not going for these kind of detailed investigations, they themselves are going to suffer based on this. Okay. So all these reservoir studies and the liquefaction, there can be a wonderful combination of geophysics and geotechnical methods based on which you can actually find out all these properties, which can be of great concern to you after spending thousands of crores of rupees in the project.
Yeah, agreed.
Very true. So we also have a knowledge member, Mr. Ranjan Ghosh. Sir, do you have any questions, sir?
Yeah, I was waiting for now. To all panel members, basically, what I was asking is that the use of advanced technologies, as is happening today, even every day, things are changing. there are enough scope of in the areas of, for example, the geophysical prospectings or any other, for example, building JJ emission reduction for buildings. Uh, Huge projects are in the initial stages going on. There are three, four big companies like Dassault, Siemens. Then the other one is I'm forgetting. Yeah. Anyway, there are three, four plus the startups are there. They are working on advanced artificial intelligence and digital twins technologies, which from what the entire life cycle of a project, starting from the design, engineering, construction, commissioning, handing over, maintenance, operations, everything. There's a huge, uh, reduction of cost, time, and energy release. Everything is happening. So, are we doing anything on these? Because, especially for Mr. Raghuvira, I just wanted to know that these are in
Yes,
building
sir.
management system. BMS, the building management systems are getting, in a new project, especially many projects are coming where the smart management systems, including utilizing the IoT sensors, and then the platform which manages the entire area of the buildings and surrounding areas. So these are very advanced and has huge potential for reducing GHG emissions in many areas. Even for PSPs also, there are applications are happening in the Schlumberger and Aramco in their geophysical prospecting for oil and gas. I'm from a oil and gas industry basically, so I am. So they are doing. Using extensively already, Aramco and Schlumberger has started doing that. They're using extensively advanced artificial intelligence, the artificial AGI, artificial general intelligence, and the agentic AIs to solve their problems regarding the GHG emissions, and also the life cycle cost management, time management, and everything. And these are all almost real time applications. So, anything is happening around this, or any plan for doing these things?
For me, sir, question is to me.
It is to all
To
the
all
panel
panel
members.
members,
Oh, okay, okay.
all the panel members,
So
because
from
it is a general topic.
okay, okay. The related to construction point of view, or the buildings, as you said, buildings and heavy industries and institutional areas. There is no doubt, sir. Actually, now the it has to be converted everything into a automation, and also a auto cutoff, and also if a human is not following, which is to be followed to reduce the energy consumption, the AI has to take care. So that much has to be implemented in almost all the projects. And while designing phase itself, these to be considered so that GHG can be reduced and everyone can be contributed. And another one is related to uh, basic considerations of a solar energy has to be considered into the utilization of every aspect of your life. Another one is the softwares available in the industry has to be incorporated by all the members of the from the inception stage to the commissioning and operation stage. Those softwares has to be utilized by the people. Unfortunately, actually, from maybe from past 20 years experience, for every project is a dynamic for me. My matrix always will start from 100 only. Even if I complete my project, again it will start from 0 to 100. If I complete 100, it is not like that. Every time the project is like that. And another one is the contribution, if we want to do also every dynamic. And now we are really lucky that this AI tools have come, and surely these to be implemented in the life cycle time of any projects, or from inception to commissioning and handing over and utilization to the site society. So that's what from my side, sir. Thanks for your valid question.
Thank you. And
Sir, I
actually, Dr. Sanjay Rana has rightly told that almost 0.5, 0.7% of the total budget or total time is utilized for planning stage. And that it just has to be reversed almost, in the sense that with these new technologies, the proper planning saves lot of, insight problems encountered by the construction people, and subsequently during commissioning, during handing over, all those things are tackled, because can be tackled, because if the planning stage are done properly, and accordingly the design engineering and everything is done. Thank you.
Yeah. Sir, so anyone would
hello.
like to add to the discussion?
Yes, yes, Suresh, definitely. Uh, First of all, very thanks to Dr. Sanjay Rana sir to enlighten us with his, kind of experience and expertise he is having. Just want to add one thing, sir. Uh, a small group, we are a small group of people. We are like a data scientists. We are working on creating some kind of use case study using quantum, or especially on climate change, cyber security, and all. So I feel we might get some answers, how to address these issues, related to, could be greenhouse effect or climate change, or could be mining areas and all, which are impacting our entire environment in a totally different way altogether, and also to the uh, to the entire engineering aspect also. So let's hope for the best, sir. I hope you might also agree to me, because the kind of new tech things are coming up. Uh, they will also make our work little bit more, comfortable, or help us to take more decision quickly, rather than what you have said. The kind of time which we take, is very less in terms of designing and all the other things and all.
That's great.
Absolutely.
So, yeah.
Absolutely. Yeah. See, just to add to what you said, uh, the technologies have a role to play in practically every aspect of environment and water. Since I am also chairman of Aqua Foundation, I've been working on water for a very, very long time. And as I always say, you can't manage something unless you understand that. Okay. And the first thing to be understood is aquifers themselves. And today, geophysics is being used in a big way to understand your underground aquifers, so you can manage your aquifers better. Because aquifer mapping is a major challenge once it comes to managing groundwater. Okay, and similar thing is applicable for climate studies, environmental studies, pollution studies, contaminant movement studies, etc., etc. So I totally agree with you, and I'm sure we'll connect, further on this. And commenting on what Ghosh Saab said, one simple sentence summarizes what you said. That is, failing to plan is planning to fail. So unless you plan properly, you actually can never think about success. Forget about achieving success. So yeah, I respect your contributions. Thank you.
Thank
I'd
you.
like just Yeah, I'd just like to add to what the panelists have told. Very rightly pointed out, AI integration into any business. Of course, in PSP also, AI integration is a very important aspect, and it is going to be an aspect which will determine whether it is your life cycle cost, or whether you're going to develop a round the clock solution, or whether it is an energy arbitrage because the slot times are very less. So involving AI into the business is going to be the future, because we have been seeing how it has been developing recently, the deep seek and all those things are creating wonders now. And I think only those businesses will be more mature and survive, who will try to adopt with the situation of AI.
Yes. True.
So, so with this, I think we come to the end of the panel discussion, and I think it was good and enriched discussion on a wide variety of topics, starting from PSP to the digital twin technology to geophysics and amalgamation of technology for reducing the cost of any project. So it was really a great session, and I hope people who are the viewers of this webinar have a lot to learn from it. I thank all the panel members for being at the for giving their valuable time and sharing their knowledge with us. Thank you so much. So we come to the end of the webinar. Thank you.
Thank you.
Thank you.
It's
Thank you so much.
pleasure.
Thank you. Thank you.
Thank you.
Thank you.